said it's how far to the left and the right. Look at these values. They are not only going up, but they are going out, right? So this is going up and out. Up and out. Because they have those arrows at the end, is that ever going to stop? No, it's not. So it keeps going forever. So what do we call that when it keeps going forever in the negative direction and keeps going forever in the positive direction? Oh, how quickly we forget. This is all real numbers. Okay. Remember, your domain is your x values. And anytime you see those arrows and they continue to go, to the left forever. I mean, just imagine Miss Thede walking into the wall and keep going, all right? And over here, same, likewise. There's no ending. So that is going to be all real numbers. Now, the range. The range is what kind of stuff? The y values. Now, the y is how high and how low can you go? Is there a lowest point on this graph? Is there a low point? Jeffrey? -4. Yeah, right here. This is the low. There's -1, -2, -3, -4. So this is y equals -4. It's the point to -4. Okay, that's the point. It's called a minimum, meaning it is the lowest point. So that graph does go down to -4, correct? It is touching it. So that means I'm talking about y and how it relates to -4. It is equal to it because it is on that line. And then it also, is it going up? Is it greater than that? Or is it going down for less than? It's going up, right? So it's going to be greater than or equal to -4. How do you guys feel about this? I feel like this is, Would you agree? Should I maybe do another one just for kicks? Let's try this one. What if I have a coordinate plane here, and let's say, this is supposed to be a straight line. Here is my graph of my line. I want to know the domain, and I want to know the range. So again, domain, those are your x values. How far to the left and to the right is this going? How far to the left and to the right? Desmond, what do you think? Is it ever going to stop? Even though this is going down, it is still going out, right? So it's never going to stop going in the positive direction. Even though this is going up, it is still going to the left. So what do you think my domain is here? Class? All real numbers. All real numbers. Now, let's take a look at how high and low we go. So the range is my y values. Okay. How high is that arrow going? Wait a minute. I guess it would be this way for you guys. Is it ever going to stop? Is it ever going to stop going down?
In the script, it says XC. It says exceed game put cross country.
That's the RDTV.
Bro, I'm trying to fix my head, bro.
It's the RDTV. Okay. So what do we think the range is going to be here? It also is going to be all real numbers.
Can you get my dandy?
Oh. Okay, so let's go to the notes.
Man, we know I put go to him every day.
Oh my gosh. I gotta turn this off. Okay. I gotta love it. So, back where we were yesterday. All right. Don't think we'll hear any more. So we're still talking about functions. Functions. Let's see. And looks like we left off here. Okay. So now we're going to see if we can figure out how something is a function or one-to-one by looking at tables. Okay? All right, so a function. Here is the definition. Is it up? No, it's not. There we go. A function shows a relationship. Function shows a relationship from the value of the domain domain, that's your x values again, to a specific value of the what? Shows a relationship from the value of the domain to a specific value of the range. Okay? And I said, think of your pop machine. An example would be like the pop machine. Okay? Your one-to-one, when we are looking at this from a table point of view, relationship, it is a relationship, has to be, I'm underlining has to be a function first. If it's not a function, it cannot be a one-to-one relationship. Has to be a function first. Then check to see that each value of the domain, has only one value. Only one value. Only one. So that means no repeats in the range. No repeats in the range. Okay? So again, we're doing this with the tables now. If you have a graph, you use the vertical line test and the horizontal line test. If you have tables, you need to think about, for a function, it shows a relationship from one value to another. And if it's one-to-one, it has to be a function first. And then we have to check to see that the domain only has one value in the range. Okay? Oh, I didn't quite finish this. In the range. In the range. All right, so here's what we're doing. We are saying, first of all, is it a function? And then, is it one-to-one? Okay, function one-to-one. So here are my x values. What is this called again when we talk about all the x values? I know you're going to get tired of saying it. Starts with a D. Rhymes with domain. Domain, yes. So this is the domain. These are your x values. So as I look at this, I have 1 going to 6, 0 going to 2, 8 going to a -3, 9 going to a -7, 1 going to a -4. Think of your pop machine. If you press 1, will it be going to 2 separate items? Not if it's a pop machine, right? You press that 1, it should be going to 1 item. So is this a function? No. Because you can't have 1 going to 6 and 1 going to -4 at the same time. So if it's not a function, can it be 1-to-1? No. So that one is no and no. Any questions about that? Tinder. I know you got a boo-boo, but come on. It's not that bad. All right, so let's look at the second one. Function. Is it a function? Is it 1-to-1? So look at your domain. Here's your domain. And how is it matching up? Well, we got -6 to 4, 5 to 1, 4 to 3, 5 to, or -5 goes to -6, 1 goes to -12. Does that seem okay? Does that seem like it's a function? Yes. Yes is the correct answer there. Now, because it's a function, then we go to the next step. Is it 1-to-1? Relationship has to be a function. Check to see that each value has only one value in the range. Okay, we don't have any multiples. Do I have any repeats in the range? 4, 1, 3, -6, -12. Any repeats? No. So is that a 1-to-1? Yes, it is. So this is a function and it's 1-to-1. Let's take a look at the next one. I feel like I'm on a game show host. Function or no function? So let's take a look. We got -2 going to 2, -8 going to 7, 3 going to 8, 5 going to 6, and 7 going to 2. Is everyone in my domain going to a specific place? Yes. So that is a function. That is a function. Yes. Right now, you really need to go. Can you wait till I finish this page? Okay. So because it's a function, now I can check for 1-to-1. I need to see, do I have any repeats here? Well, here I get a 2, and here I get a 2. Those are repeated. So it's not 1-to-1 because I have 2 x values going here. Okay? So these are repeats. So therefore, this is a no. This is not a 1-to-1 function. Okay? And let's go to the last one. Now check, we've got it going sideways now. Same thing though. Here's my x, my domain. And I want to see, is it a function? Function. And then if it is a function, is it 1-to-1? So 6 to 5, 8 to 5, -3 to 5, 0 to 5, 1 to 5. So they're all going to 5. Now think about it. If this was a pop machine and these were all different buttons to press, could it be possible that they could all have the same drink coming out? It could be. So is this going to be a function? Yeah, it is a function. Now that it's a function, I check. Is it 1-to-1? No, because they are all repeats. So 1-to-1 means there's only one. Okay? Repeats, so this is a no. It is not a 1-to-1. Any questions about that? All right. Take a look at the table at the top. The table shows the number of medals the United States won at 5 different Summer Olympic Games. Analyze the table. Determine if gold and silver are functions, if they're 1-to-1 or neither. So what's going to be my domain here? Any ideas? What? The year, yes. So these years are going to be your domain, okay? And then this is going to be your first Y value, your range. And then this is a second range. So you have to look at them separately, okay? While I am taking care of this, see if you can figure out, is it 1-to-1? Or it function first, then 1-to-1 for the first one. And then is it a function or 1-to-1 for the second one? So what's going on? You what? Doing what? When was this? Okay. What's your last? Anderson? So just for future reference, I know your finger's probably really hurting. I mean, that's right in the middle of a lesson. So a better time to do that would be like going from bell work into the main lesson or earlier, okay? Or maybe when I was done with the lesson, because that just breaks it up. So 9-4. Okay. For restroom or what? Yeah. We can go now. Huh?
You talking about now?
All right. So years to the number of gold medals. Here. You need to fill it in. Years to the number of gold medals. Is that a function? Is that a function? Makendra, what do you think? Years to gold medal. Is that a function? Is there a relationship going from the year to the medals? Yes. So here's how we're going to do this. We're talking about year going to the gold, okay? And we're going to say, is it a function first? And then is it 1-to-1? And she said, yes, it is a function. So we're looking from here to here, here to here, here to here. Okay. So then, is it 1-to-1? Why or why not? Jordan says no. Why not? Yeah, we have numbers repeating in our range. So we have 2 of them there. We have 2 of them here. These are repeats. So this is a no. So it's a function, but it's not a one-to-one function, okay? Then we have year going to silver. So we need to look here, from here to here, from here to here, here to here, here to here, here to here. Is that a function? Is it a function? Oh, Kathy, what do you think? Is it a function to go from the year to the silver medals? Does each one go to another something? Yeah. So this is another yes. And then as you look in the silver medals, are there any repeats? I don't see any repeats. And you got to check that carefully. So that means this is also a yes. So yes, it's a function. Yes, it is one-to-one. And the bronze, we're not going to worry about the bronze, even though we have that. We could do it. We don't really have time. Any questions about that? Still haven't made it to the doctor. All right. Discrete and continuous. Functions can be discrete, continuous, or neither. You might want to underline those or do something with that. Okay. Come on. Come on. This thing just goes off. Real world situations where some numbers are reasonable are modeled by discrete functions. A continuous function is graphed with a line or an unbroken curve. Okay? It just goes on forever. A function that is not continuous is called discontinuous. Okay? And it's going to have possibly like a little hole in it. Like this. This would be discontinuous. It's got a hole in it. Okay? It's like a breach. A discrete function is a discontinuous function in which the points are not connected. A function that is neither discrete nor continuous may have a graph in which points are connected, but it is not continuous everywhere. And this is what I would tell you. If it is discrete, it's going to look like dots. It's going to look like a bunch of dots. So the D with discrete is the D with the dots. Now I know discontinue does have a D also, but that's what we're going with. So examine the functions. Determine whether each function is discrete, continuous, or neither. Then state the domain and range. So we can't get away from domain and range. Very important. All right, so the first one. The function is blank because it's a curve with no breaks or discontinuities. Discontinuities. Is it discrete, continuous, or neither? What do you think? Eric, what do you think? Discrete, continuous, or neither? It keeps going on, and it's got arrows at the end. It's never on the end, so that is continuous, right? This is continuous. I put that above because I can't write it that small. Because you can assume the function continues forever, the domain and range are both all real numbers. Okay? Domain and range are all real numbers. Because it's going up and out and down and out. Any questions about that one? Let's turn the page. Letter B says g of x, just meaning that graph. This function is blank. There are continuous sections, but there is a break. Here's that break right there. What do we call that? discontinuous. Discontinuous. Okay? Because the function is not defined at that point where x is equal to 2, the domain is all values of x except where x is equal to 2. Because it is open at that particular point. A function is not defined for when y is equal to 1. So the range is all values of y except where y is equal to 1. And we will not have to name ranges and domains like that very often. And the last one for the day. This function is blank because it's made of distinct points. Distinct points or dots. The dots of D is discrete. D-I-S-C-R-E-T-E. There are two spellings for discrete, but the one with E-E-T is not the right one. Look at the domain and the range here. Okay. It says the domain is -3, -2, -1, 1, 3, and 4. Remember, these are your x values. So these are all the x values of these points. So this point is -2, -2. This point is 1, 1. Okay. This point is 4, 2. And what do you notice about these points? If anything, do you notice anything about them? Those are some nice points, Miss Thede. Yes, they are. But they are put in numerical order. Okay? From least to greatest. Least to greatest. And they don't necessarily match up because -3 and -3, there is no -3, -3. Okay? There is no point like that. So it's just from least to greatest. Okay? All right. Any questions on the notes that we took today? We talked about continuous. We talked about discontinuous, where you got a stop somewhere in that line. We also talked about discrete. And we talked about the tables. So let's take out your homework. Your homework I gave you yesterday. Did you get the one that was below it? Homework? So let's see. 8-1 is the homework. Remember, all of these homework assignments are going to be worth 10 points. It's going to be 6 points for just completing it. And I do mean completing like all of it. And then 4 points will be targeted for actual correctness. Okay? So let's take a look at this. Number 1, look at the graph, identify the domain and range. So if you see arrows, there's a good chance, depending upon where it's at, think about, is it going on forever to the right or to the left? Could be all real numbers. Is it going on forever for the range, up and down? Okay. Let's do one of these together. How about let's do the second one of number 1 together. So this one right here. Domain and range. Domain, how far to the left and right am I going? Guys, take out your homework. Come on. How far to the left and right? Somebody's at the door. Miss Sanaya. How far am I going from the left to the right? This is the audience participation part. What? This is the homework. Homework 8-1. How far to the left or right am I going on this second problem of number 1? Doesn't stop. So what would I put there for the domain? All real numbers. That's that funny looking R. Okay. Range. Do I have a highest point? I do. It's right here and right here. And if I count that, it is 1, 2. So I am saying my Y value compares to 2. Does it reach point 2? Yes. So that means it's equal. And then is it going up? Is it greater or less than? Less than. Is it a function? Remember, you got to do that vertical line test. Vertical line test. Is it a function? Yes? No? Yes? Is it 1-to-1? This is the horizontal one. Is it only going through once? No. There you go. That's what you're doing for that. So you need to complete front and back. I am going to make this due Friday now, but just know we are starting a new section tomorrow and you will have another homework assignment to be given to you tomorrow. But this one will be due on Friday, okay? Don't wait till tomorrow night. Take a look at it now, and then if you have questions, you can ask questions, okay?